Thank you for joining me. I'm glad to have you there. Today I want us to look at conversion of galvanometer to an ammeter. How we can convert a galvanometer so that we can be able to use it to measure current. And of course, we know that a galvanometer is nothing but an instrument for detecting very low current. So those currents that cannot be detected by an ammeter, then we use a galvanometer to detect them. Today, I want us to look at how we can use the same galvanometer to measure an appreciable amount of current. Now, let's go. The first one we have here is our galvanometer. Most times it can be represented with this deflection, arrow deflection. Now, if we have a galvanometer like this, and of course, current is flowing from somewhere. Now, the only way to convert a galvanometer to an ammeter is by connecting a very low resistance resistor in parallel with the galvanometer. And when you do that, we have it like this. Now, this is the resistor. This resistor, because it's a very low resistor, connected in parallel. We now have it like this. This is the resistor. That resistor is called shunt. So in other words, we can say that the shunt is a very low resistance resistor connected in parallel with the galvanometer. Okay, if this is the galvanometer, now current is flowing from somewhere. Now, this current will still pass through. On getting to this junction, it can now come down here. Remember, this is a pointer instrument. The current here, current flowing through this one, we can call it arrow IG, which is current through the galvanometer. This galvanometer has a resistor. Now, the resistance of this galvanometer is arrow G. And our interest is to have a converted ammeter from the galvanometer. Now that ammeter, it can be here, so we can call it a converted galvanometer. Okay, because already this galvanometer has been converted to an ammeter to record current. So this I here is the current capacity. The range of current it can carry. Why this Ig here is the current through the galvanometer. This Rg here is the resistance of this galvanometer. Rs here is the shunt. And of course, like I said earlier, it is a very low resistor connected in series with this galvanometer. Okay, now we have that from Ohm's law, we have PD across this shunt. PD across the shunt is equal to the PD across the galvanometer. PD across the galvanometer. PD across the galvanometer. I already said galv. Now from Ohm's law, we now have, remember Ohm's law says V is IR. Now PD across this shunt is the current capacity. The current capacity of this converted galvanometer minus the current flowing into the galvanometer. So we now have I minus Ig multiplied by Rs, which is the shunt resistor, now is equal to PD across the galvanometer. PD across the galvanometer is current flowing through the galvanometer times the resistance of the galvanometer, so which will give us Ig multiplied by Rg. So in other words, this is our formula. We now have that current, we have the resistor, the shunt itself is equal to Ig Rg all over the current capacity minus current flowing through the galvanometer. So this is our formula. Okay, now let us take one or two calculations to understand this concept very well. Now we'll take the first one. The first one says, and of course these questions are A-level questions. Explain the conversion of the galvanometer, which has a full-scale deflection of 25 milliampere and a resistance of 10 ohms, to an ammeter capable of measuring 4.025 ampere. So to an ammeter capable of measuring 4.025 ampere, and calculate the value of the resistance required. Okay. Now we have from the question that they say calculate the explain the conversion of the galvanometer, which has a full-scale deflection. Now, the current that will give it full-scale deflection, of course, is the IG, current through the galvanometer, that will give the galvanometer full-scale deflection, which is 25 milliampere. And the resistance of the galvanometer is 10 ohms. Now, the capacity of that ammeter is 4.025 ampere. That's all. And they say calculate the value of the resistance required to do this, of course, which is the shunt. Now, from here, most times you can continue with your milliampere, or you convert it to ampere. So if you convert it to ampere, we now have that IG is equal to 25 all over 1000. And if you do that, we now have 0.025 ampere. 1, 2, 3. Okay, so this is our current through the galvanometer. Now we quote our formula that says I minus IG multiplied by RS is equal to IG multiplied by RG. Now from here we substitute. Now if we substitute it, we have the current capacity, which is 4.025 minus current flowing through the galvanometer, which is 0.025 multiplied by RS equals current through the galvanometer is 0.025 times the resistance of the galvanometer, which is that. Now, if we do this, we have, and of course, 4.025 minus 0.025 will give us 4. 4 times RS will give us RS, which is equal to 0.025 times 10 will give us 0.25. Now, if we do the necessary calculation there by making RS the subject, we have that our RS will give us 0.25 all over 4. And if we press our calculator, we have 0.25 divided by 4 will give us 0.0625 0.0625 ohms. Therefore, we cannot, at this point, we can do the explanation. Remember, the question says, explain the conversion of a galvanometer with full-scale deflection list. So, in other words, we cannot say that, yes, the conversion is possible. You can do the conversion by connecting a resistor of this value, 0.0625 ohms, by connecting it in parallel with the galvanometer. So that is the answer to that question. So let us take another question. The second one says, a galvanometer has a resistance of 5 ohms. By using a shunt wire of resistance 0.05 ohms, The galvanometer could be converted to an ammeter capable of reading 2 ampere. What is the current through the galvanometer? What is the current through the galvanometer? So we clean our board. Now if we do that, we have, from the question, a galvanometer has a resistance of 5 ohms. That means RG is 5 ohms by using a shunt wire of resistance. Now the shunt now RS is given to be 0.05 ohms. The galvanometer could be converted to an ammeter capable of reading. That means I itself is 2 ampere. What is the current through the galvanometer? IG is what we are looking for. Remember, our formula says I minus IG multiplied by RS is equal to IG multiplied by RG. Now, if we substitute these values, we have, under this, we have 2 minus IG multiplied by RS. RS is 0.05, which is equal to IG multiplied by RG. RG is 5. Now, which will give us 0.5 times, we have 2 times 0.5. 2 times 0.05 will give us 0.1 minus 0.05 IG, which is equal to, remember, as an IG there. So, which will give us 5 IG. 5 IG. Now, we collect like terms. 0.1 is equal to 5 IG. We send this one here plus 0.05 IG will give us 0.1 equals 5 plus 0.05 will give us 5.05 IG. Make IG the subject. IG will give us 0.1 all over 5.05. Therefore, we can have that current through the galvanometer is equal to 0.1 divided by 5.05 and 0.1 divided by 5.05, which will give us 0.019 ampere. So this is the value of our current. I will still take another question. That question says, okay, we have this question. Haven't solved the other 2 questions. Please, this one is left for you to solve this one. Please solve it and put the answer in the comment section. Now, this question is one of the questions that came out in JAMB. Now, the question says, the diagram below illustrates the conversion of a galvanometer of resistance 2 ohms to an ammeter. The galvanometer gives a full-scale deflection for a current of 10 milliampere. Calculate the value of R. And of course, here they use the ordinary R. You and I know that, yes, this R here is the shunt. So please get the answer and then put it down in the comment section. If this lesson was helpful to you, please give it a thumbs up, give it a like, share this video, and then please, if you have not subscribed, please do it to subscribe to this channel. Thank you very much.